What's up, you guys? It's another tutoring with Mr. Sorrels, and today we're going to be going over natural selection and evolution. All right, hopefully this gets you guys prepared and ready for the content check that we have coming up tomorrow, Wednesday, March the 8th. I hope that all of you guys are here, ready, and prepared to go bang out this evolution content check. So, without further ado, let's get right into it. What is natural selection? What is natural selection? Let's establish a basis of what natural selection is. Is it picking one person and saying, hey, you're naturally selected? Is it picking an animal and a person and saying, hey, you guys, I picked you guys two apiece? No, that is not it. So let's get some firm understanding on what natural selection is. Some traits are better suited for the environment than others. Individuals with adaptive traits are more likely to survive and reproduce. It's all about survival of the fittest. All right, let me give you guys an example. Who's going to do better in school? The Mr. Sorrels that has all of his school supplies, brings his laptop, has his charger with him, and is prepared for school every single day? Or is it the Mr. Sorrels who brings his laptop one day, forgets his backpack Tuesday, and the rest of the week he's checked out? The only thing he bringing is a phone, a pencil, and some AirPods. Which Mr. Sorrels is going to be more successful in his educational environment, aka school? It's probably going to be the Mr. Sorrels that brings his backpack, has his laptop, has his charger, has his school supplies, and all the things needed to get the grades he wants, correct? But if I don't come to that environment properly prepared, I'm going to fail. That's all natural selection is. If you don't come to that environment with adaptive traits or beneficial traits, you're not going to be able to, one, survive, and two, reproduce. All right? That is what natural selection is. That's what it's gonna be. That's what it's gonna stay. All right? Let's move on to evolution. What is evolution? All it is a change over time. Anything that you can pinpoint a difference at and a time change at is evolution. So, let me give you guys an example. A tree. You plant a tree, it starts with a little seed this big, and over time, it evolves. It grows. It forms leaves. It begins to make branches. It begins to expand. That tree has evolved from its first shape, from its first form. We can see a gradual change over time. Who thought of this theory? Was this Carlos Linnaeus? No. That was the guy from taxonomy. The father of evolution is Charles Darwin. Charles Darwin is the father of evolution. Remember that, you guys. Remember that. Charles Darwin. And he knew, just like we're learning, that there's multiple types of evidence for evolution. There's many different ways that we can go pinpoint, figure out, think about, and come to conclusions about evolution. So, let me go over and remind you guys and reteach a couple of the types of evidence for evolution. We got vestigial structures. Vestigial structures. What are those? Bones that are no longer useful. So, think about a tailbone. Think about a tailbone. It's right up on your lower back. Do we have a tail? No. We as people, as humans, do not have a tail. So what is the purpose? What is the use of a tailbone? Well, it's a vestigial structure. We no longer have use for that bone. But does it mean it just goes away or it falls off? No, it's going to be there. It just doesn't have a function. So we can know that we have evolved as a species because we have a tailbone with no tail. Gotcha. Homologous structures. Homologous structures. Homo. What does that mean? We got to remember our prefixes. Homo, same. So homologous structures. Structures from common ancestry. Same ancestry. Don't think the same, just think common. But whenever you see homo, you know that it's either the same, it's alike, or it's common. Alright, so just keep that in mind for homologous structures. Analogous structures. Those are structures with similar adaptations. Similar adaptations for analogous structures. So, and this is just an example, you guys. If I know that Coach Lamone's class is always 20 below zero, and Miss M knows that Coach Lamone's class always feels like 20 below zero, and me and Miss M, we didn't discuss it, we didn't talk about it, we didn't plan for it, but on Wednesday we come in with our coats on. We have similar adaptations. When we get cold, we grab a jacket. Similar adaptations. Analogous structures. We'll keep it like that. Biogeography. Similar organisms found in different places. So let's talk about that for a minute. How would that fall under the category of evolution? Well, if I could find a certain type of cockroach in my house, and then I go to my friend Pete's house, and he has the exact same cockroach, same color, same speed, same trait, they could both fly. Both types of cockroaches can fly. And I'm making this a very vivid example because I want you guys to understand. Biogeography, similar organisms found in different places. So let's go back millions of years ago, thousands of years ago. Pangea went the whole world and its continents were one. So how did these animals all end up in different places? Well, Mr. Sorrels got some background knowledge, probably migration and herding, and went this way and went that way and settled that way and settled this way. But the point is, biogeography relates to similar organisms found in different places. All right? Similar organisms, different places. That was one we really had trouble grasping. All right? So be sure to remember that. Next, fossil records. You guys know what fossils are. You guys are great at this. You guys can identify fossil records. We all know what that is. Digging up bones and studying and keeping a record of how the differences in the bones. All right? You go keep it at that. You guys are great at fossil records. Developmental homologies. I know that was a tongue twister. But we're not going to let that stop us. Embryology, the studying of fetuses, babies. So comparing babies, comparing the fetus, comparing how it first starts off, its first form. All right, that's usually when you'll see a picture of a baby, a chicken, a pig, a turtle, and they'll say, okay, compare this phase to phase 2. Compare phase 2 to phase 3. What are the differences in the growth process? Here, we see things like tails being formed into legs. We see gills being formed into lungs or air passages. We see eyes begin to get color. All right, so you guys just keep that in mind. It's the studying of the fetus, the studying of the baby. Molecular homology. This is one we have really struggled with, and all it is the simplest one. The simplest one. And I just want you guys to think molecular. Molecule. Molecular. Molecule. all it is the differences in DNA and amino acid sequencing. So you guys remember ATG, TGA? It's just the differences, the changes in DNA, in RNA, and in the amino acid that's going to come from both of those. Real simple. Real simple. All right. We're in the part of the video where you guys have gotten your review and reteach. Now, here's some things I want you guys to remember going into tomorrow. Adaptations. Adaptations are when a species becomes better suited for the environment they're in. That's all it is. Better suited for the environment it is. So if I am living in a hot environment, the best thing for Mr. Sorrels to do is to probably, one, drink some more water, and two, stay inside. If it's hot and it's 100 degrees outside, and I don't like being a hot boy. Y'all know what that means. I don't like being no hot boy. I'm going to go inside where the AC is at. So adaptation is just a species becoming better suited for the environment they're in, all right? Another thing I want you guys to remember, mutations are a change in what? No, not RNA, DNA. Mutation, any change to DNA. Any change to DNA. Recombination, chromosomes exchanging DNA. This usually happens during meiosis, not mitosis, meiosis, all right? You got to say it long so you guys can know the difference. Meiosis. All right, another one I want you guys to remember is, what's the difference between natural and artificial? I'm going to teach you something. The natural is the real. That's, okay, random. Natural, you can't fake that. Artificial, it's the fake, it's the fugazi, it's the misconstrued, it's the twisted and the turned. So artificial selection, I want you guys to remember these words: force, fake, impossible without man-made force, unnatural. Artificial selection is a man-made, human-forced change. If you see a Chihuahua and a Pit Bull, breed it together. That is artificial selection. The owner or the breeder has chose these two specific organisms and brought them together artificially, not naturally. All right? Genetic drift. Genetic drift. All that is the frequency of genotypes. The frequency of genotypes. And I'm going to break this down even simpler for you guys. How your DNA letters look. How your DNA letters look. That's all it is. Don't make it more than what it has to be. The frequency of genotypes. Let's talk about the bottleneck effect. Because you guys just throwing out answers when we ask you what the bottleneck effect is. It's something, aka an event or disaster, that changes the genetic makeup. All right? We've seen this happen in Ohio. We've seen this happen in Fifth Ward, Texas. So, bottleneck, something, an event or disaster changes the genetic makeup of the population. Simple, we'll keep it at that. Founder's effect. Certain genotypes start a new, completely different population with one specific genotype being more prevalent. What does more prevalent mean? Being more seen. All right? If Mr. Sorrels says, okay, I don't want to reproduce unless you have hands that completely align equally. You know how some people's fingers be real long and stuff? I want all of your fingers to match up equally. So I want them to go straight across. Founder's effect would be me saying, okay, all of my fingers go straight across. They're completely equal. I want to find somebody whose fingers are completely like mine and they're completely equal, and I want to have one population and one complete race where all of the fingers are equal across their hand. That would be the founder's effect. You guys are ready for this evolution content check. You guys should go kill this. I'm proud of you guys. And Bearcats, go be great. That's all for tutoring with Mr. Sorrels today. I kept you a little longer than I usually do, but it's all for you guys' success and continued growth in biology. So you guys tomorrow go kill this evolution content check, and Mr. Sorrels will be there clapping you on the whole time and the whole way. You guys be safe, be easy, and I'll see you guys in class.